Welcome, trigonometry students, and we're getting into vector operations. I again have a split screen of the homework on the left side and the notes on the right side. I know there are 11 problems, but it's going to feel like you're back in Algebra 1 after you complete this homework assignment. If you haven't already, these notes, you can actually print this out. It is a Word document on PowerSchool. But if you don't have a printer, you're not able to print them out, you really just need to kind of handwrite a few of these. This is an important part, and some of these parts are important. Not every single one of them you need to write down, but you'll take note on the important parts here. Just remember what a vector is. A vector is direction and magnitude. Direction is just showing you which direction it's going in. Is usually indicated by the A and the B value. The magnitude is how long the segment is. All right, let's start with question 1 here. And question 1 has point 1 and point 2. So let me go ahead and draw a picture of this picture. So the picture looks something like this, and it starts at -7, -4. So -7, -4 is going to be somewhere down here, point 1. And then point 2, 4, 3 is going to be somewhere up here, point 2. So it's starting there and it's going up in this direction. Now, in the previous homework assignment, if you remember, basically from this location, you could just count over, count up, and identify what is the direction of it, like what's the A and the B value. Well, sometimes that's just ridiculous to graph it, plot the points, and then count, and you're just wasting a lot of notation, a lot of time there. Oops, I didn't mean to do that. So if you notice on the first statement here, let me go back to that. It basically just says take the terminal point minus the initial point, and that's key. Write that down. Terminal minus the initial. So when you go through this, when you write the terminal minus the initial, it'll be 4 minus -7i plus 3 minus -4j. This will actually become a plus, so it becomes 11i. This becomes a plus, so it becomes 7j. And again, if you don't trust me here, you could just go back up here and just count over, and it will be 11 over and 7 up. It's giving you the direction of it, and that's exactly what you type in this notation. That's the first couple problems there. I believe that was question 2. That's question 3. You're just really going with the direction. Now what's going on is they want you to add the vectors together. So if you look at the vectors here, and again, let me try to draw this. I'm just going to make a rough sketch of this picture. Vector U is going 9 to the right and 7 down, and then this one's going 10 to the left and then 9 up. So let me just make a rough sketch. I'm going to make the U one red, so it's going to be 9 over, 7 down, so it's going in that direction. That's U. We'll make the blue one V, so was that 10 to the left and 9 up, so V is somewhere up here. Well, what you're kind of doing here is that you're taking these two vectors and you're applying the forces together. So you could imagine taking the blue dot at the end of this one and then going, 10 to the left and 9 up and figuring out what's the final location there. Just a second, I'm going to get rid of that. I'm going to make it in a different color so you could imagine that. Or you can imagine taking the red, the U, and starting here at the end of the blue and going 9 to the right and 7 down. But they're going to result in a final location. But the nice thing about this is, and again, it's kind of like you're back in Algebra 1, you just have to add I terms with I terms, J terms with J terms. So in this case, if I just take 9 minus 10, that will be -1i. Don't forget the I in the J term. J is what? -7 plus 9, which will be 2. Plus 2j, and what the resultant, that basically is called the resultant force. It's the result of the forces. My picture is not drawn well because the resultant force should be at -1, +2, so it should be up here. But if I actually had a graph, I guess I could break out some graph paper just like this and actually kind of model out the whole thing. But again, you're just doing the basic operations, just kind of combining things together. Subtraction's the same thing. Just make sure you watch out when you subtract V. that means it's going to actually make this into a +2 and that into a -3, just like how you have to distribute a -1. So be careful with that. This is called a scalar. Scalar is no different than distribution. It's really just, again, let me just draw a picture of it. I'll make a rough sketch of it. It's going, what, -2 and then up 6. So I'll just make the picture going this way. So it's going to go -2. I'm actually going to do it in red, up 6. That is vector V. Well, it's imagining if the force is being applied again, it's going to go over 2 again and up 6 again in that direction. So you're really just trying to figure out what is the result of this. But again, it's just like going back to algebra 1. If you take 2 and distribute to both of these, oops, I'm starting to do the problem in my head. I'm starting to think ahead there. Distribute, you get -4i plus 12j. And again, if you actually just start it from the origin and count it over, it would be left 4, and then count it up, it would actually be up 12. Not too surprising. And again, don't forget to include your I and j. Even says put your I and j in the expression. Same thing there, just distribute -9. Same thing here. Distribute, you're just going to take 5 and multiply it by the w vector. Take 5 and distribute by the v vector, and then just add all the components together. Just make sure you keep everything organized and detailed there. Make sure you watch out. Let me wrap up with this problem here. This one's getting into a scalar and then a magnitude. So we'll go through and I'll describe exactly what I just said there. So again, this vector, and I'm just trying to I'm making a rough sketch of these pictures. So really, if you want a more detailed graph, just go ahead and print yourself some graph paper, and you could actually plot these out and see the direction they're going in. So this one's going, what, 5 to the right, 2 down. And it's doing that 4 times. So 5 to the right, 4, it just keeps on going that way, that way, that way. And so really, this is vector V 4 times. And then it says magnitude. Well, magnitude is going to tell you what's the length of that whole segment. Well, I could make this into a triangle and then just do Pythagorean theorem. And that's really all my work here. That's what I'm going to end up doing here. Let me scoot this up so I can actually show my steps. So first step, take 4 times the vector. Oops, that's supposed to be a minus in there. Yeah. Minus, distribute, you get 20i minus 8j. That's basically the final location of this point of the 4th vector. Now, whenever I do the magnitude again is just like doing Pythagorean theorem. So 20 squared plus 8 squared. So do notice, whenever I take the 8 squared, I don't write it as -8. Be careful, I see that mistake a lot. I see students writing -8 squared. And your calculator will treat that as -64. Obviously, that's not the answer there. So whenever I do that, I'll get 400 plus 64. The only bad thing about this is I believe this does simplify. Let me go ahead and keep writing this out. Oh, dang it. Let me get my pen back. So square root of 464. Just a sec. Let me grab my calculator. I am going to break this down. I got to find perfect squares for it. 4 goes into it, so this breaks down to 4 times 116, which if you take the square root of both of those, that'll be 2 times the square root of 116. The problem, 116 will break down. I should have picked a larger number to go ahead and do that with. That's 4 and 29. So square root. Square root of 4 is 2, but I'm going to take that 2 times that 2 and get 4 square root of 29. Wow. Let me go ahead and type that in. Let me get that highlighted in there. So 4 square root of 29. Check answer. And then there's your final solution. And that's exactly what you're doing on the last problem. Definitely, if you have questions or concerns, I am holding Zoom meetings. Definitely sign on your assigned days, and I will meet with you and we can go over the lesson, talk about what's going on with the course or anything. If you have any questions, make sure you're getting the homework done and make sure you know what's going on. Thank you. Have a good day.